Hello students, welcome to the Quick Solutions All India AIATS Test Series JEE Advanced 2020 Test 2A Paper 2 Physics. Let's go to question number 1. Question 1 says, a capacitor A of 1 microfarad is charged to a potential difference of 110 volt and then connected to a circuit as shown. Switch S is then closed. Capacitor B and C were initially uncharged, then in steady state. Option A says charge on A is 30 microcoulomb. Option B says charge flown through the switch is 60 microcoulomb. Option C says potential difference across B is 60 volt. And option D says potential difference across C is 20 volt. Let's evaluate the options. So we have capacitor A initially charged to 110 volt and then switch S is closed. So initially, before closing of switch, what is the charge on capacitor A? The charge on capacitor A initially, right, is equal to C, which is 1 microfarad, into V, which is 110 microcoulomb. So it's 110 microcoulomb, which is the charge on capacitor A initially. Now the switch S is closed. And so after closing of switch, so we have the 3 capacitors like this. So charge here was 110 microcoulomb, and we consider that after closing of switch S, Q amount of charge has flown in the circuit. So that means the charge now here is 110 minus Q. And here it is Q, it's minus Q here, it's Q here, it's minus Q here. And this is the condition in steady state. We simply apply Kirchhoff's loop law. We have already taken care of the charge. And once we apply the Kirchhoff's loop law, we have 110 minus Q divided by 1 is equal to Q divided by 2 plus Q divided by 3. This is equal to 5Q by 6. This means we have 110 equal to 11Q by 6, which gives us Q is equal to 60 microcoulomb, which means charge on A now will be equal to 50 microcoulomb, right? So charge here is now 50 microcoulomb. So option A is obviously incorrect. Let's look at option B. It says charge flown through the switch is 60 microcoulomb. Well, we see that 60 microcoulomb has actually flown in the circuit, so option B is correct. Potential difference across B is 60 volt. Well, potential difference across B will now be equal to Q by 2. That means 30 volt. So option C is incorrect. And let's look at option D, which says potential difference across C is 20 volt. Well, potential difference across C will be equal to 60 divided by 3 or 20 volt. So option D is correct. So for question 1, options B and D are correct. Let's move on to the next question. Question 2 says, a ring of radius r is fixed and is uniformly charged with charge q. A small particle of mass m and charge minus q is released on the axis of the ring from a small distance a being much smaller than r from center of ring. Then option A says time period of oscillation is 2 pi under root pi epsilon naught mrq by capital Q small q. Option B says time period of oscillation is this much. Option C says maximum speed of the particle is this much. And option D says maximum speed of the particle is this much. We can see that the question is based on the concepts of electrostatics and oscillations. So let's find the expression for the restoring force that will be acting on the particle. Okay, so we have this ring here, and let's assume that at an instant distance from the center of the ring is x. The charge here is minus q. The ring has charge plus q uniformly distributed. So the force, electrostatic force applied by the ring on the particle is going to be equal to F is 1 by 4 pi epsilon naught q into x divided by x square plus r square, or rather r square plus x square to the power 3 by 2 into minus q. So we put a minus sign here and the small q is coming over here. Now, a being very small compared to r, x will also be very small compared to r, because the maximum value of x is going to be a only. That being the case, we have acceleration a is equal to minus capital Q small q x by 4 pi epsilon naught m. Now since x is very small compared to r, so in the denominator we can ignore x, and r square to the power 3 by 2 will be simply rq. This means angular frequency omega of the SHM. It also proves that the motion will be SHM, and the expression for angular frequency omega is now under root of capital Q small q 4 pi epsilon naught m into rq. Now coming to the time period of oscillation, time period t is 2 pi by omega, so it is 2 pi into 4 pi epsilon naught m rq divided by capital Q small q. If we take this 4 outside of this under root sign, we can see that this answer that we have got matches with option B. So option B is correct and option A is incorrect. Coming to the maximum speed, we know the maximum speed is going to be omega into amplitude. So Vmax is omega times A. A will be the amplitude of this motion, is equal to A times under root capital Q small q upon 4 pi epsilon naught m times rq. If we look at the options, we can see that it matches with option D. So for question 2, options B and D are correct. Let's go to the next question now. Question 3 says, a source of sound is located in a medium in which speed of sound is v, and an observer is located in a medium in which speed of sound is 2v. Both the source and the observer are moving directly towards each other at a speed v by 5. The source has frequency f0. Then option A says apparent frequency observed by the observer is 11 f0 by 8. Option B says apparent frequency observed by the observer is 8 f0 by 7. Option C says apparent wavelength observed by the observer is 11b by 5 f0, and option D says apparent wavelength observed by the observer is 8v by 5 f0. Obviously, the question is based on the concept of Doppler effect in sound. Let's draw a simple diagram. So here we have, let's say, the source, and this is medium 1. Let's call it medium 1. Let's say this is the boundary, and this is medium 2, and here is the observer. According to the question, the source is moving towards the observer with speed v by 5. The observer is also moving towards the source with speed v by 5. Both are moving directly towards each other very clearly. And the frequency emitted by the source is f0. Now what about apparent frequency observed by the observer? Well, what we can do is find the wavelength of the wave between S and O in medium 1 first. So if the source had not been moving, then let's say the wavelength would have been lambda naught in medium 1, and that lambda naught will be equal to the speed of sound, which is v in medium 1 divided by f0. Because of motion of the source, the wavelength is reduced and the wavelength in medium 1 because of motion of source is equal to, let's call it lambda 1, will be equal to lambda naught, which is V by F naught, minus distance traveled by the source in one time period, and that distance will be equal to V by 5 F naught. The time period will be 1 by F naught, and this value is 4V by 5 F naught. Now, as the wave is entering into medium 2, the speed is doubling, and the speed is doubling. This clearly means that the wavelength will also double because the frequency will not change because of change in medium. So that means lambda 2 is equal to 8V by 5 F naught. Now, coming to the frequency observed by the observer, that frequency will be equal to speed of sound relative to that observer, and that speed of sound is equal to 2V plus V by 5, and that speed is equal to 2V plus V by 5 because the sound is coming towards him with speed 2V in medium 2, and the person is going towards the source with speed V by 5. So that relative speed of sound with respect to the observer in medium 2 is 2V plus V by 5 and divided by the wavelength in that medium, and the wavelength we have just found is 8V by 5 F naught. Let's simplify this. This is equal to 11V by 5 into 8V by 5 F naught, and this value is 11 F naught by 8. So this is matching with option A. Option A is correct and option B is incorrect at the same time. Regarding the wavelength observed by the observer, we had already found the wavelength will be 8V by 5 F naught. So option D is also correct, option C is incorrect, and that means for question 3, options A and D are correct. Let's move to the next question now. Question 4 says, when heat of amount Q is supplied to an ideal monoatomic gaseous system, the gas performs work of Q by 2 on its surrounding. Then, molar heat capacity of the gas is 2R, molar heat capacity of the gas is 3R. Option C says P is proportional to 1 by root T, where P is pressure and T is temperature. And option D says V is proportional to root T, where V is volume and T is temperature. Let's apply the first law of thermodynamics. Here the heat supplied is Q. So Q is equal to delta U, change in internal energy, plus work done, which is again Q by 2. So this means delta U is also equal to Q by 2, and the work done also is equal to Q by 2, which is given in the question. Now we can write Q as NC delta T, and that will be equal to 2 times delta U, because work done is also equal to delta U. So that means it is equal to 2 times delta U. It is 2 times N into delta U for a monatomic gas will be, this is 2N into delta U, which is 3R by 2 delta T. In fact, 2 times delta U will be 2N 3R by 2 delta T, and which means the molar specific heat C for the process is equal to 3R, which means option B is correct, option A is incorrect, where C has come out to, considering that it's a polytropic process in which the value of molar heat capacity is 3R. We know that C can be given as, for a polytropic process, CV minus R by X minus 1 if the process is PV to the power X is equal to constant. Now since we have the value of C and CV, we can find the value of X and we can get the equation of the polytropic process. So let's put the value of C, which is 3R. So we have 3R equals CV, which is 3R by 2 minus R by X minus 1. On solving, we get R by X minus 1 equals minus 3R by 2 or minus 3X plus 3 equals 2, or which means X is equal to 1 by 3. So we have the equation PV to the power 1 by 3 is a constant. Let's look at variation of pressure with temperature. So let's eliminate V and we can put V equal to nRT by P. So we have P into T to the power 1 by 3 by P to the power 1 by 3 is equal to constant. That gives us P to the power 2 by 3 is proportional to 1 by T to the power 1 by 3. And if we take the power of 3 by 2 on both sides, we find P is proportional to 1 by T to the power 1 by 2, which is matching with option C. So option C is correct. Let's also evaluate option D. So for evaluating option D, we eliminate P from this equation, and we can, for P we can write T by V, because PV is equal to nRT. So for P we can write nRT by V, and if we do that, we get T into V to the power minus 2 by 3 is a constant, and so V is proportional to 1 by T to the power minus 3 by 2, which doesn't match with option D. So option D is incorrect. Options B and C are correct. We can now go to the next question. Question 5 says, consider the circuit shown in the figure. We have this circuit given to us, and options are about current through the battery, current through branch AD, current through branch BC, and potential difference between points D and C. Okay, let's look at the circuit carefully. Let's redraw the circuit. This is a 20 volt cell, and from point A we have two resistances coming. One goes like this, another like this. Let's call this point A. Let's call this point D. Between A and D you have this 4 ohm resistance, and this point is C. This is 2 ohm resistance. Between point C and D we have a 4 ohm. So between point C and D we have this 4 ohm. And then between point C and B there is a 4 ohm resistance. So let's say this is point B and this is 4 ohm. Whereas between D and B there is an 8 ohm resistance. So 8 ohm resistance is here, and the negative terminal is connected to B. You can check, we have accounted for each and every resistance, and the given circuit can be redrawn as I have just redrawn. Now if you look at the redrawn circuit, it's very obvious that the network is a balanced Wheatstone bridge, because 2:4 is same as 4:8. And now solving the question becomes very easy. The effective, to find the current through the battery, we need to find the effective resistance. We know that we can ignore this 4 ohm resistance, which is forming the bridge between D and C. So we have 2 plus 4, 6 ohm in parallel with 4 ohm and 8 ohm, that is 12 ohm. So 6 and 12 in parallel will give you effective resistance, which we can call RAB, equal to 6 into 12 divided by 6 plus 12, and 72 by 18 is 4 ohm. The effective resistance of the network is 4 ohm, and so the current to the battery I is equal to 20 divided by 4, or 5 ampere. So option A is absolutely correct. Let's look at other options. It says current through branch AD is 2 ampere, Well, current through AD will be same as current through DB because there is no current in DC, it being a balanced Wheatstone bridge. So current through AD will be equal to 20 divided by 12 ampere, and which clearly does not match with B. So B is incorrect. Let's look at current through branch BC now. Current through BC is same as current through AC, and that current will be equal to 20 divided by 4 plus 2, 6. So which means C is also not correct. Let's look at potential difference between points D and C. Potential difference between points D and C we know it will be 0 because there is no current in the resistance DC of 4 ohm. So D is also incorrect. So for question 5, only option A is correct. We can now go to the next question.